All right, this is section 4.2, properties of division. Before we actually get into this section, I want to go through and actually do kind of our bell work together. So I'm going to take 20,548 and divide it by 32. So you probably remember this from like elementary school. So this is our long division here. And remember, we're going to start trying to take 32 and dividing it, or taking the numbers inside and dividing them by 32. Now we can't take 2 divided by 32, 20 divided by 32. We have to take 205. So if you take 205 divided by 32, and I'm actually going to sort of do this off to the side because you're going to see we're going to want to do this again later on. If you grab your calculator, you get 6 point something something. All right, so 6 goes up there. Then you take 6 times 32. We multiply down and around. We get 192. Then we subtract. Bring the 4 down. Now we're going to take 134 divided by 32. And we get 4. Multiply down and around. 128. Subtract. Bring the 8 down. And then 68 divided by 32 gives us 2. And then I'm actually going to leave it as 4. I'm not going to start adding decimals and continuing on. All right, so when we divide this, we're actually going to get 642. So that's kind of the whole number part. And then we get a remainder of 4. All right, so I want you to kind of keep that in mind because we're going to use a really similar process as we go through a couple different types of divisions today. Okay, so the first one is long division, and like I said, we're going to use this from 4th grade or elementary school. So again, same type of problem, same type of setup. So x squared plus 3x plus 1 is going to go on the outside. Now, if you'll notice, we've got x to the 4th minus 16, but we are missing an x to the 3rd and x squared. We're missing all those terms. So really that means the coefficient is 0. You do have to add those in. If you leave them out, we're not going to have enough stuff to divide by. All right, now the easy thing with this is if you can stay organized, these problems become really, really easy. So all we're going to do is we're going to take the first thing on the inside, so x to the 4th, and we're going to divide it by the first thing on the outside. One way I kind of like to think of this, we're almost estimating. So I understand that there's a plus 3x and a plus 1, but really when we look at our estimation, we really just want to know how many times x squared can go into x to the 4th, or what is x to the 4th divided by x squared. So this goes back to our rules of exponents, and we're going to have x squared. Now, the big thing here, you've got to have them lined up. So because it's an x squared, it goes above the x squared in my original problem. Now, I'm going to multiply over here. So I'm going to take x squared, and I'm going to just distribute. So x to the 4th plus 3x to the 3rd plus x squared. All right, now, just like we did with our long division on that first slide, we're going to subtract. All right, now when we subtract x to the 4th minus x to the 4th, that's 0. Okay, it better be 0. If it's not 0, then you've done something wrong. All right, so then I have 0 minus 3. And again, I'm just really going to worry about my coefficients because as long as I've added in my placeholders, everything should line up well. So 0 minus 3 is negative 3, and that's in our x to the 3rd column. 0 minus 1, that's negative 1x squared. And then I've got to bring this part down, and we keep going. So our next step, we're going to take, again, almost like estimation, negative 3x to the 3rd divided by x squared. Remember, that's really a 1. So negative 3 divided by 1 is negative 3. X to the 3rd over x squared, that just becomes x. So keep things lined up. And now we're going to distribute again. Negative 3x times the part on the outside Everything I'm writing over on the right side here, I don't need to see that on your work going forward. A lot of times with this distribution stuff, I think you can see what it's supposed to be. You can just kind of do that mental math wise. So if you don't want to write the stuff on the right, I'm okay with that. So negative 3x times x squared is negative 3x to the third minus 9x squared, and then minus 3x. I'm going to subtract again. We do have some negatives show up, so here's where you have to be really careful. All right, negative 3 minus negative 3, that's negative 3 plus 3, so that's gone. Negative 1 minus negative 9, so negative 1 minus negative 9, remember that's really plus, so that's going to become 8x squared. 0 minus negative 3, that's going to become 3. And then I bring down the last thing. Now, obviously, this is nice because there are no decimals with these polynomials, so we know once we're done, we're going to be done here. 8x divided by x is just 8. Multiplied down and around, we'll get 8x squared plus 24x plus 8. We're going to subtract. So 8 minus 8 is 0, 3 minus 24 is negative 21x, and then negative 16 minus 8 is negative 24. So the part down here at the end, that's my remainder. And the part up top above the line is our answer. So how we would actually write this answer would be x squared minus 3x plus 8. And then we're going to put plus, actually, we'll put plus negative 21x minus 24 all over the part we divided by. Okay, so we can write it that way, or we can write it as x squared minus 3x plus 8, and then r negative 21x minus 24. All right, now here in just a minute, we're actually going to show you a quicker way because obviously this takes up a lot of room. This took 6 minutes to do one problem like that. That is definitely not necessarily reasonable to do for a bunch of problems. The next example I want you to look at, and so this is kind of in a different order in your notes, but this goes back to what we did in this section 4.1 in terms of graphing. So remember when we graphed, if you were going to graph x equals 2, x equals negative 1, and x equals 3. All right, so those are our zeros, but here I want to write the polynomial. I want to go backwards on this problem. All right, so what I need to think of is, okay, I got x equals 2, so what did it come from? Well, it came from x minus 2 equals 0. This came from x plus 1. This came from x minus 3. And so if you remember back to what our problems look like in section 4.1, we would just multiply all these factors together. Now most of the time our problems were already factored, but for whatever reason, if we want this polynomial, here we can just FOIL. So I'm going to have x squared plus x minus 2x minus 1. That's just multiplying the first two. Unfortunately, you can only multiply two things at a time, two binomials at a time. And then you just have to be really careful. I'm going to multiply x squared times everything. Now I'm going to multiply x times everything. Now I'm going to multiply negative 1 times everything. And then we combine our like terms to get our final answer. It's x to the third. You've got negative 3x squared minus x squared, so that's minus 4x squared. I've got 3x. Oops, sorry, I made a mistake up here. This needs to be a negative 2 up here. So that needs to be a negative 2. That's a negative 2. I'm sorry, guys. That's going to change over here, so that's going to be minus 2x plus 6. So we got 3x minus x, that's plus x, and then the constant is just plus 6. So there's our polynomial. We'll do those some more in the next couple sections, adding in some other things. So just be really careful and then be ready for that. A couple important theorems that we're going to use. First of all, the second one actually says a factor, a number is a factor if and only if the remainder is 0, or what we get when we plug in the value is 0. So keep that in mind. We'll come back to that also. And as we look through these, we're going to use something called synthetic division. Now, synthetic division, you're going to see these next couple examples are going to take us maybe 2 minutes combined. And then once you get good at these problems can take you 5 to 10 seconds. So they're really, really nice. Now, one thing to really pay attention to, this only works when we're dividing by x minus n. So if you look back at our example 1 from the top, we could not use synthetic division because we were dividing by x squared plus 3x plus 1. So we'll talk about what to do if you don't have an x minus n type thing going on. Now here's the steps, and we'll go ahead and read through the steps, but then I think as you see the example to make a little bit more sense. So we're only going to take the number from x minus n, and we're going to put it in a box. Then we write the coefficients. You must include zeros across the top row. We bring the first coefficient down, and then we're going to get in this sort of repeated cycle. So we're going to multiply the box times the number below and move it over. So box times the number, move it over. And then we're just going to repeat until we run out of numbers. Now, these last 2 points are really, really important. The remainder can be a couple different things. And we'll look at that as we get a couple answers. All right, so our first example. One thing I need to check is that I'm dividing by the right thing, and it is in the correct form. Okay, so my first step says to take the number from x minus n and put it in the box. So I'm going to put a 2 in the box. Now, one thing that you can remember here is usually when we think of stuff inside parentheses, we think backwards. All right, because I think when you look at this binomial, you want to put -2 in the box, right? But because it's inside the parentheses, we're just going to put the +2. Now we're going to take our coefficients. All of our coefficients are there, so we'll get 1, -3, 1, and 5. We're going to put a line. Okay, the next step is bring the first coefficient down. That means bring the 1 down there and write it right there. Now we're going to multiply the box times the number below and move it over. So 2 times 1 and move it over. Then we're going to add down. So -3 plus 2 is -1. And now I'm in the exact same spot as before. 2 times -1, move it over, we'll get -2. Add down, 1 minus 2 is -1. 2 times -1 again is -2. Add down, and you get 3. We are out of numbers, and so you are done with your problem. Now, the kind of cool thing about this is you have a ton of information. This doesn't look like anything, but there's a ton of information here. Okay, so the first thing is when we divide, a lot of times we actually want the parts that are left over. So we started with an x to the third, and when we divided x to the third divided by x, we had an x squared. All right, so this line right here is the coefficients of this new problem. So I'm going to get x squared minus x minus 1. Now we've got a remainder, so we're going to write it just like we did before, 3 over x minus 2. That's our actual answer when we divide. If you wanted to divide by that binomial. Now, I will tell you a lot of the times we're really just going to focus on this 3. We're really going to focus on the remainder. But if I ask you to divide and I want the whole thing, then that there is our answer. All right, now the next thing that's really cool, it says find f of -3. Now, a lot of times we just plug this into our calculator, right? We put 2 times -3 to the 4th plus 5, and we keep going. All right, but one way that we can do this is we can use synthetic division. So we're going to put the number in the box. We're going to put our coefficients across the top. So 2, 5. Now, I notice there's no x squared, so I do need to put a placeholder, 0, -2, -8. Right, now, I'm going to go through this actually a little bit quicker so that you see like the kind of the cool part of this problem. All right, so we bring down 2, multiply down and around, multiply, add, multiply, add, multiply, add, and there you go. So once you have these set up, they go really, really fast. And the awesome part about synthetic division with these types of problems, there's our answer. So the remainder is what we would get when we evaluate that polynomial for f of -3. If you want to plug it into your calculator and check, again, you can do 2 times -3 raised to the 4th, all that. After you hit equals, you will get 25. So that is the end of section 4.2, properties of division. We looked at some long division, and then we also looked at some synthetic division.